Hi and welcome to Probability with me, Bill Haining. Today's objective in this session is to find out what probability is and how to simplify it, how to calculate probability and place this on a probability scale, convert the fraction answer to a decimal and a percentage, work out the probability using diagrams, tables and trees. Now let's look at level 1. Now probability is calculating how likely an event is to happen. Now, if something has a low probability, it's unlikely to happen. If something has a high probability, then it's likely to happen. Probabilities are always shown as fractions, decimals, or percentages. Now, the formula is fairly simple. It's possible results over outcomes. Now, when you're dealing with probability, every scenario, your starting point is creating this scenario, this fraction, and I'll show you how to do that later on. Or R over everything. So R over everything, and R stands for the results you want over all. Now the key to probability is to understand how to create that formula of fraction. Now using the formula provided to work out the answer to the following questions. Work out the probability of selecting a vowel from the word high field. Well, there are three possible results as you can see because there is three vowels, I, and E. And there is a total of 9 words. So you've got a 3 in 9 chance of picking a vowel from the word Highfield. And then you can simplify that. You find a common number between 3 and 9. And then you simplify it down. Both numbers can be divided by 3 as you can see here. So 3 divided by 3 is 1. 9 divided by 3 is 3. Alright, therefore there is a 1 in 3 chance of selecting a vowel. That's how it works. Let's look at another question now using the formula. A bag contains 12 different colours, 5 red, 4 white, 2 blue and a pink. What is the probability of selecting a blue counter? Again, there is two possible results because there is only 2 blues. But there is 12 counters altogether. So you have a 2 in 12 chance which can be simplified to 1 over 6. So you have a 1 in 6 chance of picking or selecting a blue counter. Now, what is the probability of rolling an odd number when you roll a dice? And show your answer as a fraction. So again, you can see here, there are 3 odd numbers on a dice from 6. So you have a 3 in 6 chance. Okay, so you can simplify that to 1 over 2. Now, write your answer to the question as a decimal. Well, that's fairly simple. All you do is with fractions, that's the dividing line. So all you do is take 1 and divide it by 2. So the answer is 1 divided by 2 is 0.5. And you can see from experience 0.5 is just the same as a half. Okay. Now the final thing you may be asked to do, you may be asked to write your answer to the question as a percentage. Again, this is fairly simple. You just take the decimal you've created and you multiply it by 100. And you can see 0.5 times 100 is 50%. And you can see all these things mean the same thing, a half, 0.5 and 50%. So if you stick to that pattern of creating the fraction first, converting it to a decimal by dividing the top by the bottom, and then multiplying by 100, you can answer that question in any of the denominations. So keep that in mind. Right, let's look at another question. What is the probability of selecting a red card from a deck of 52 cards? Again, you can see there are 26 red cards in a pack of cards, so there's half. So you've got a 1 in 2 chance of picking a red card. Now, the second part of the question is, what is the probability of selecting a picture card from a deck of 52 cards? And it says show your answer as a decimal. Well, just like before, you select, you create the fraction. So you can see there's 12 picture cards in a pack of 52. You can simplify that to 3 over 13. You don't really need to. All you really need to do is divide 3 by 13, which will give you an answer of 0.23, and that's it rounded off. Okay, but if you divide 12 by 52, you'll still get 0.23. So at that point there, you don't have to simplify it. Now, there is a worksheet associated with this video. All right, that will be in the link box. So have a look for it and try it and have a go, and I'll give you some practice. Now let's look at probability lines. A probability line is the simplest way of displaying your results. This is a probability scale. You can mark a point along this scale to demonstrate a probability. So let's have a look at it. Now, what is the probability and likelihood of tossing a coin at landing on a head? Okay, you can see you have a 1 in 2 chance. Okay, and if you think about the scale, right, the scale goes from impossible all the way through to certain. And these are the 5 main areas. So you can see if it's a 1 in 2 chance, then it must be in the middle there somewhere. It'll fit right in the middle of the the scale. Because you see all answers must go from 0 to 1. All right. Now again, this could be fractions, decimals, percentages, but you see how it works. Okay. Now anything that's impossible to happen will fit right here. Anything that's going to happen will fit there. But there is these areas in between, like unlikely and likely. You have to figure out where your fraction fits within that scale. So how likely is it you will roll a 4 when rolling a 6-sided dice? Okay, you can see there's only one 4 on a dice. So you've got a 1 in 6 chance. And where would that fit on the probability scale? Well, it's unlikely you're going to roll a dice. And you can see there, if you imagine splitting that into 6 parts, that scenario, you would see that 1 in 6 would be around here somewhere. So it would be in the unlikely area. So these are the main areas on the probability line. Now let's look at an exam style question. Okay, Linda has a full box of handmade cards that she's taken to a craft fair. The table shows how many cards in each of the categories Linda has, and you can see the table laid out in front of you. Okay, Linda picks a card from the box at random. What is the probability that Linda picks out a thank you card from the box? Alright, so what you do is you show your answer as a decimal and a percentage. So what you have to do is do the R over all fraction first, okay? And you could see that 41 is your top. There's 41 chances of you picking out a thank you card. Okay, and if you add up all the totals together, you can see it comes to 278. So you have a 41 in 278 chance. So that's your answer as a fraction. Now you convert it to a decimal just simply by dividing the top by the bottom. And that gives you 0.15, which has been rounded off. Okay, and then to convert it to a percentage, you just simply multiply by 100. And you can see you have a 15% chance of picking a thank you card from a total of 278 cards. So that's probability. Now, a workplace gives one raffle ticket to its workers for each sales target that they meet. Each month, one ticket is drawn at random for a prize. The chart shows the number of sales targets met by each worker. Now, the question is, what is the probability that Jim will win the April draw? And it says complete the probability diagram below to show your answer. Well, if you look at the target Jim has got, you can see that he has got 5 tickets. So you go to the top of the bar graph, work your way across, and you can see he's met the target 5 times. So he has 5 tickets. And that's your top number when you're creating a fraction. Now the bottom number is everyone added together. So if you add all the totals together, you can see that Jim has a 5 in 20 chance or a 1 in 4. It's the same thing. Okay, now where would you put that in the scale? Well, if you take the bottom number, the 4, and spread it across the scale, you can see there that goes from 0 to 4, all right? And then all of a sudden, you put your marker in where you think it would go, and you can see there that a 1 in 4 chance would fit on the scale there. Okay, so there's your 1 in 4 chance, there's your 1 in 2 chance, there's your 3/4. Okay, so that would be in the unlikely area, so it would be unlikely that Jim would win the April draw. May be presented with a table and asked to work out the probability of an event. Okay, now a group of dancers raised some money for charity. Here is some information about the money raised. and you can see you could be presented like this. Okay. Now one of the dancers is chosen at random to give money raised to charity. All right. What is the probability that this dancer raised money is less than £10? So what you do is you select the number of dancers who have raised less than £10, add them together, which you can see there is 38. Okay, now 30 of the 60 in total raised less than £10, so the probability is 38 out of 60, or 30 over 60. The question doesn't ask you to simplify it, so that's the answer. But it may ask you to simplify it, it may ask you to convert it to a decimal, it may ask you to convert it to a percentage. Just follow the routine I've shown you already. Now let's look at expected frequency. With probability, all scenarios must add up to 1 or 100%, just like the scale. Okay, so you can see there, if 3/4 of students pass the maths exam, then a quarter must fail. Okay, because 3/4 plus a quarter is 1. If 0.8 trains arrive on time, then 0.2 must arrive late. And you can see 0.8 plus 0.2 is 1. Okay, and if there's a 35% chance of rain today, there must be a 65% chance of no rain. So 35% plus 65% is 100%, and that's just the same as 1. Okay. Now again, there is a worksheet associated with this video, so look in the box below and you will find it. Now that's level 1 completed. Let's look at level 2. Okay, let's go back over expressing probabilities as a fraction, decimal, and percentage. Let's look at the routine. Now we know from level 1 that the key to probability is to look to create a fraction. At level 2 you may be asked to take this a little bit further. For example, you may be asked to give your answer as a decimal or a percentage. It's a straightforward process. It's just a fraction to a decimal into a percentage. Okay, so you can see here that 1 divided by 2 is 0.5. This is your decimal, so 0.5 times 100. To convert that to a decimal, to a percentage, you multiply by 100 and that gives you 50%. Okay. Now you may also be given a fraction in a question, then be asked to further calculate. For example, you may be given more than one option or one choice. So let's have a look. Okay, so Sam and Mona are playing with a coin. They take it in turns to throw the coin. What is the probability that they both get tails? And it says write your answer as a fraction. Okay, so write it down. Okay, so you can see Sam throws the coin at first and he has a 1 in 2 chance of getting a tail. Okay, then Mona takes a turn to throw the coin and you can see she has a 1 in 2 chance. Now this is the point where most people get it wrong. Okay, they seem to think you add these together. You don't. All right, when you're presented with any question in maths when there's no symbol in between, then the Bodmas rules apply. You must automatically multiply. Okay, so you can see 1 times 1 is 1, 2 times 2 is 4. So the answer is 1 over 4. Let's have another look. The probability that a salesperson will get an order from a visit tomorrow is 1 in 4. Okay, now she has 2 visits tomorrow. So what is the probability that she will get orders from both visits? Okay, so you can see on the first visit she's got a 1 in 4 chance of getting an order. And on the second visit she's got a 1 in 4 chance of getting an order. Okay, and again, this is where most people make mistakes. Because there's nothing in between to tell you what to do, you simply multiply. Okay, and you can see that 1 times 1 is 1, 4 times 4 is 16. So the chances of the salesperson getting 2 orders tomorrow is 1 in 16. Here's some examples of questions you may face in the exam. Okay, if you would like to have a go at it, stop the video and see what the answer is. So let's have a look at the answer. So here is a fair spinner. Circle the probability that the spinner lands on an A. Okay, so you create your fraction. You can see how many A's are there. There's 1, 2, 3, 4 A's. All right, and there is 1, 2, 3, 4, 8 sectors. Okay, so from that you can deduce that you have a 4 in 8 chance of landing on an A. All right, and then you just divide 4 by 8. That gives you 0.5. Okay, and you can see the probability that a spinner lands on an A is 0.5. Another question, if you want to have a go, pause the video. Alright, so a probability that a festival goer chosen at random has travelled by car is 14 over 25. What is the probability that they did not travel by car? It says give your answer as a decimal. Well, remember all scenarios must add up to 1. Okay, so 14 over 25 travel by car. That means that 11 over 25 people didn't travel by car. Because you can see if you add 11 and 14 together, it comes to 25 over 25, which is 1. Okay, then you just divide 11 by 25, and then gives you an answer of 0.44. So the answer is a 0.44 chance of not travelling by car. Let's look at tables, diagrams and trees. At level 2 you may be presented with tables and trees. These are just visual representations of probability. You need to know how to interpret these, but how you calculate them is just the same. So let's have a look. Okay, when there are two events, it is useful to write down all possible results in a table for multiple events. And you can find the probabilities using the table. Okay, so here's an example. Two spinners, both numbers 1 to 5, are spun and the outcomes are added together. So there's your two spinners, right, and there's all the outcomes added together. So you can see 1 plus 1 is 2, 1 plus 2 is 3, and so forth. All right. Now, what is the probability that the result is a 7? Okay, well, there are 25 possible outcomes, as you can see, right? And how many sevens there are? There's only 4 possible results because there's only 4 sevens. Okay, so you create the probability 4 over 25. And so you have a 4 over 25. And you can now convert that to a decimal or a percentage depending on what the question asks. Okay, so 4 out of 25 chance of getting a 7. Let's look at probability trees. A probability tree is a visual tool used in functional skills to calculate combined probabilities of a sequence of events. Now you throw a two six-sided dice, right? So you take a dice and you throw it up. Now you can see there's a table of scenarios. So you can see there to throw any number, you've got a 1 in 6 chance of landing the number of your choice, which means that you have a 5 in 6 chance of not landing the number of your choice. Okay, and it's the same for the second throw as well. All right, so let me show you how it works. Now imagine you want to throw, you want to land a 5. So you can see when you throw it the first time, okay, you have a 1 in 5, 1 in 6 chance of landing a 5 and a 5 in 6 chance of not landing. So this would be a winning scenario, this would be a losing scenario. All right, so you can see that if you take that route, now this is known as the origin where you start from. So if you take that route, it gives you a 1 in 6 chance. Now you want to throw your second dice, and you can see there, again, you've got a 1 in 6 chance. All right, so what do you do with these numbers? Well, you know from before that if you've got more than one choice or one option, you automatically multiply it. Bodmer's rules apply. So you can see you've created two fractions and you multiply it. And multiplying is the easiest of all calculations of fractions. You just do 1 times 1 is 1, 6 times 6 is 36. So you have a 1 in 36 chance of landing two fives, one after the other. Okay. Now let's look at the next scenario. What are the chances of throwing 1 5? Well, let's imagine you start at the origin and you go down this route. You failed to get a 5 on your first throw. You can see because you got a 5 in 6 chance against you. But the second one, you have a 1 in 6 chance. Okay, so how do you calculate the probability? Just the same. Okay, so you can see 5 over 6 times 1 over 6 is 5 over 36. And you can see that you've got a bigger chance of landing 1 5 than you have of 2 5s. All right, and that's probability. Okay, now let's you have a go. Have a look at that question there. Mai has this information about 100 flowering plants in a shop, and you can see the table before you. So work out the probability that this plant will have a large flower and a long stem. So pause the video, have a go, and see how you got on. All right, so how did you do? Well, let's have a look. You have a 29 in 100 chance because you can see if you add up all the scenarios together, it comes to 100, but you can see there is only one section here which is large and has a long stem, which is 29. So you can see you just do 29 over 100. So you have a 29 in 100 chance of landing a flower with a long stem. Right, let's have a look at this probability tree. Okay, now filling the missing numbers. Okay, pause the video, see how you got on. How did you do? All right, you can see there that all scenarios must add up to 1. So if that's 0.3, that must be 0.7. Okay, let's look at the next one. Okay, if this part here is 0.15, this part must be 0.85. So all scenarios must add up to 1. Okay, now let's look at a question. Work out the probability that a person under 30 has an electric car. So pause the video and see if you can come up with a scenario or the answer to what the probability is of someone getting an electric car under 30. So pause the video. How did you do? Fairly simple. You can see there, you start at the origin, follow the line, it'll take you to under 30s. Alright, then you follow the line, it'll take you to electric, and you can see it's 0.3 and 0.4, and just like before, there's nothing to tell you what to do with these numbers, so Bodmer's rules apply, you multiply. Okay, so 0.3 multiplied by 0.4 is 0.12. And if you got that answer, well done. Now, probability is used in various real-life scenarios to assess the likelihood of events occurring. Now, here's some examples which you may come across. That's why it's called functional skills. Weather forecasters use probability to assess the chances of rain, snow, or other weather conditions on a given day in a specific area. For example, they might say there's an 80% chance of rain between 2 o'clock and 5 p.m., indicating a high likelihood of rain during those hours. You may have heard the weather forecast presenter using percentages. All right. Sports betting, work out the odds based on past history. Risk assessment, insurance and finance. Probability is also used in risk assessment in fields of finance, engineering and healthcare. All right. Simulations and modeling. Probability is used to create realistic simulations and analyze the results. And these are just a few examples of how probability is used in real life to help us make informed decisions, assess risks, and understand the likelihood of different outcomes in various fields and situations. And that's probability. Thank you.